Hello, dear viewers. I am Dr. Neha Singh. I'm working as assistant professor with ABES Engineering College, Ghaziabad, in the Department of Applied Sciences and Humanities. Today, the topic we are going to take is analysis of coal. So, coal, as we know, is a very common fossil fuel which is produced from the vegetable debris under the conditions of high temperature and pressure over millions of years. During this process, the pure form of carbon is concentrated inside the coal so that when we combust it, it becomes oxide in combination with oxygen and gives us energy to work. Now, coal is classified into four forms, that is peat, lignite, bituminous, and anthracite. Peat here is the lowest quality of the coal, having the least amount of carbon percentage, while anthracite is the premium quality of coal, having percentage of carbon more than 90%. So, here, on the basis of percentage of carbon, we have classified our coal. Peat is having around 50 to 60 percentage of carbon. Lignite is having 60 to 70%. Bituminous is 70 to 80% carbon percentage, and anthracite is beyond 90%. How do we got to know how much carbon percentage a given coal is having? For that, we'll be studying the analysis of coal, which is further of two types, proximate analysis and ultimate analysis. In this video, we'll be taking the proximate analysis for better understanding. Now, the proximate analysis is actually a process in which we define the properties associated with storage, transportation, and combustion. Proximate analysis further contains four parts, that is the determination of moisture percentage, determination of volatile matter content, determination of ash percentage, and fixed carbon of coal. Let's start with the moisture content. It's important to determine the moisture present in the coal because water, which is a form of moisture, it does not support combustion. So if the coal is having high amount of moisture, it will not burn properly and it will not give a good amount of calorific value. Now the method, how do we use the method to calculate the moisture content? What we do, we take an oven, maintain its temperature at 0.5 to 110 degrees centigrade, and let it preheat. In the meanwhile, we take the coal sample that we have to analyze in 1 gram, suppose a unit weight is taken. Suppose we take 1 gram, we powder it finely, we weigh it in a silica gel crucible and keep it in the oven for 1 hour. We know that water boils at 100 degrees centigrade. So around 105 to 110 degrees centigrade, all the water will be evaporated when the crucible is kept in that atmosphere for 1 hour. After this, we'll take out this crucible and cool it into a desiccator. Desiccator is a jar of glass which is containing dehydrated salts. So it will not let the coal attain the moisture again. Now when it is cooled, it is weighted. Its weight. Suppose the initial weight was 1 gram and final weight is 0.9 gram because some moisture has been removed. The loss in the weight will be 1 gram minus 0.9 grams. This will be put in the formula in the place of loss in weight upon weight of coal, which was 1 gram. And when we'll multiply it to 100, it will give the percentage of moisture. If this percentage is higher, that means the coal is not of good quality. But if it is lower, that means it can be of premium quality. Now we'll go to the volatile matter determination. In this method, we'll determine how much volatile gases are trapped inside the coal. Volatile matter too does not contribute to the calorific value because it does not burn. It simply is the trapping of non-volatile volatile gases into the coal, which when the coal is burned, they just move out. They don't burn or attain or contribute to the calorific value. So now the determination is done by the same crucible that we have obtained after the removal of the moisture content. Right? This crucible is now kept in muffle furnace, which is maintained at the 950 degrees centigrade temperature, and we'll keep our crucible only for 7 minutes. When we'll take it out, there'll be a loss in weight, which is suppose 0.7 grams. So what we'll do, we'll take initial mass 0.9 gram and we'll minus 0.7 grams into it, and we'll divide it by the 1 gram of coal, weight of coal sample taken into 100. And we'll get the volatile matter determination. Next is ash. Ash is the residue left after burning of the fuel. So whichever thing which does not burns in the fuel is known as ash. As we know, it cannot be used. Therefore, it is a liability to the fuel. More ash a fuel is giving, that means it is giving the low calorific value, right? So how we will calculate the ash? We'll take the crucible which we obtained after the volatile content analysis, and we will keep it again into the muffle furnace. Now the temperature will be 700 degrees centigrade and the duration will be half an hour. Everything will burn except for the ash. Ash will be left behind. We'll take out the crucible, cool it down, weigh it, and suppose the weight is zero point 0.3 grams. So the percentage of volatile matter will be 0.3 grams upon 1 gram into 100. That will be the ash content. The last part is determination of fixed carbon. Here we do not have to do any analysis. Simply we'll just take the values of moisture content, volatile matter content, and ash content, add it and subtract it from 100. Whichever value will be coming, it will be belonging to the carbon. That will be the fixed carbon present in the coal. So that was all from my side in the analysis of proximate analysis of the coal. Thank you so much.